I think like questions 10 and 11, you saw things like this. It's going to be something you see all the time in this class where other geometry, or when you solve a geometric problem and you start setting it up, it might incorporate algebra that you don't use on an everyday basis. Okay, but it is something that we will continue to use on a regular basis in here. And it becomes a very important aspect of a lot of classes after this. Not only to recognize, the geometry that allows me to relate the things together, but then when I get an equation, can I pull from my knowledge of working with those equations maybe last year or the year before and work through and solve them, okay? Understand, at the beginning of the year, towards like Christmas, after Christmas, okay, so the beginning of the new year, you get a yellow piece of paper, blue piece of paper, and they ask you to go have your teacher sign it so you get in another course, right? And they ask you to sign that because they want to make sure that you have the prerequisite course information and criteria, and you've shown success in that information to be successful at another course. So you had to show that you were successful in Algebra 1 to do stuff in geometry, okay? This is the reason why, because you come across situations in geometry that forces you to know something about algebra, okay? And obviously, this is a whole chapter in algebra. I can't teach the algebra chapter and the geometry chapter at the same time, right? Okay, so there's some stuff that is going to be called upon you if you don't remember how to do it. Are you just going to be okay with that, or are you going to use the resources that I provide you to get better? Okay. What I hope right now is that we can set up the geometry. The geometry should not be things that are extremely difficult. Okay. But the first thing I want to recognize is that there's a lot of different relationships here. There's at least 3 relationships that I see that we can deal with. Okay. And each one of those is going to garner a equation. So let's set those equations up. All right. Let's first look at those 2 angles together. What is the relationship that you know about those 2 angles together? Okay, they're supplementary. They form a linear pair, right? Okay. And we know linear pairs are supplementary. So I'm going to write that equation down. I'm going to say, x plus, is it okay to say x plus 3y? Do that addition. So x plus 3y should equal 180 degrees. Okay? So let's say that's the first equation I come across. Now, what is wrong with that equation? Maybe not so much what's wrong with it, but what is problematic about it? 2 variables. Okay? And we have 2 variables. We can't solve it directly for a numerical value. Now we can do some stuff. We can say, well, x is equal to 180 minus 3y, right? But I don't know what x is until I know what y is. Or I could say y is equal to 1/3. It's actually going to be negative 1/3 x plus 60. Okay, when I solve this one for y. But that doesn't tell me what y is unless I know what x is, right? So I can solve for x and I can solve for y, but it provides me an expression that incorporates the other variable. Maybe not something we really want to do. There's other ways around this problem instead of doing that. Okay. When we get 2 variables in an equation, you need to realize that you need another equation with the exact same 2 variables. So maybe you look at those 2. What is the relationship between those 2 angles? They're vertical, so they should be the same or equal. So 5x minus y equals 2y. Okay? There's another equation. It's equation number 2. Okay? We could honestly be done with developing relationships here, because the idea, and this if you go back to your algebra, this is referred to as a system of equations. And the more we use these, the more we'll just refer to it as just a system. Okay? But we've got a system of equations, and to be more formal, it's actually a system of linear equations. But that's enough to be able to get through the math to solve it. Okay? But what I want you guys to think about is that when we start solving these problems, there might be 2, 3, 4, 20 different routes that we can take to solve a problem, okay? And I want you to sit and think, maybe it takes 10 to 15 seconds, maybe sometimes longer, to sit and look at that, analyze it, and say, are there any other routes to take? Are there any better routes to take? Because that might take, 3-4 minutes to solve it that way, okay? But there should be another relationship that we can see here that makes things extremely simple. And the other relationship is to look right there, isn't it? What do we get, or what is the relationship between those two angles? Supplementary again, right? Okay. So I'm going to create an equation. I'm going to add those together. I'm going to 5x plus x gives me 6x, right? Negative y and positive y. When I combine those together, what's that give me? 0y, and that's just 0. So I don't write that down, right? But they should be supplementary. So I get that. Now, what is nice about equation 3 then? I can solve for x. Okay? I can get x to be 30 here. Okay? And now if x is 30, that x is the same x that we use in all these other relationships, right? So I should be able to, in either one of these, doesn't really matter which one, come in and put x in. So I'll put it in this first one. I get 30 plus 3y equals 180. 3y is 150. Y then has to be 50. And now I've solved that system, okay, in a much more efficient manner than I would have if I just looked at the blue equations and dealt solely with the blue equations. Okay? Now, if you are a person that focus just on the blue equation, that's fine. You can do it. You will still get the same 50-30. I want to go through that process with you. Because there will be times where this equation does not exist. That simplicity just isn't there. Okay? And actually, let's do a problem, because that was, I think, question 10 maybe. Let's do question 11. And in question 11, all right, so it's the same concept. I'm going to start looking at relationships. I know for certain that those two things should be supplementary, right? So I'm going to go 5y plus 3x should equal 180. Okay, it's equation 1. Okay, can I say similar argument about those two things? All right, so I'm just going to combine those. That's going to be 4x plus y plus 76 equals 180. Okay, now I'm going to do something here that you can either do now or do later, but I'm going to move that 76 to the other side. You'll see the benefit of doing that here in a moment. So subtract 76 from both sides, and I'm going to get, what, 104? We'll see why we do that here in a little bit. And now do we still have that relationship? Okay, so equation 3, 5y is equal to x plus y plus 76. So we get those three relationships, and hopefully you see how this contrasts to what we just did in the last problem. In the last problem, that one of those three equations was able to be solved easily for x or y, right? Okay. Here we don't have that, okay? A lot of times maybe those other equations they refer to as maybe explicit equations because they only have one variable in them. And you can easily solve for x or solve for y. Here we don't have that, okay? So when you have this situation, okay, all you have to do, and it doesn't matter, okay, it doesn't matter which two equations you use, as long as they incorporate both variables, okay? I'm going to pick two of those three equations, and I'm going to put them together, okay? And do a procedure that will allow me to solve for x and y. So that procedure, I'm going to take just the blue one and the red one. So I'm going to take 3x plus 5y equals 180. And then I take the red one, which is 4x plus y 104. Okay. Now, it could have been, I could use the green one with the blue one, I could use the green one with the red one, I could have created a couple different options, right? But they all should yield you the same result. Okay? You address them all the same way. So maybe we'll do this example showing it with 2 and 3, equations 2 and 3, and see if we get the same results back. But what we want to do is we want to set something up that looks like that. Okay? And this was the benefit of taking all these equations. Why I rewrote equation number 2 and I moved that 76 to the other side. What our goal is to get columns in which we have like terms in that column. We have our x's. In this column, we have our y's. And then over here in this column, we just have our constant values. Okay? Things that are non-variable. And the hope is, when we set these up, and you saw this last year, that when we add straight down, we either get 0x to show up, or we get 0y to show up. Does that make sense? 0 times x is just 0, right? It makes that variable disappear. Okay? Well, if I do that now, if I add straight down, I get 7x and 6y, right? So nothing disappeared, nothing canceled out. If you remember from last year, the word we're looking at here is eliminate. Okay? So this process is referred to as elimination. Okay? But we learned last year that we're allowed to alter or transform any one of those equations, or both of them, so that things cancel out. So which one do you want to alter? The bottom one. Which variable are you going to try to cancel out? Y. Okay? So this y value is a 1, right? Okay, coefficient's 1. We want it to cancel out with the y that's above it. So it has to become 1. Yes, it has to become the opposite. Okay? We want these two numbers to be additive inverses. Okay? So it means they sum to 0. So I'm going to multiply this thing by whatever number it's going to take to get that coefficient to become the opposite of 5. So I need to multiply by negative 5. Okay? And that's going to transform that red equation to negative 20x minus 5y equals now, okay, 5 times 100 is 500, right? 5 times 4 is 20, so that's going to be what, 520? Negative 520? The number one place that people start making mistakes with systems of equations is that when they multiply one of their equations by, some people call it a scalar, whenever we multiply by that, we forget to multiply every single part. Most people will multiply these two things over here, and they forget to multiply the 1 over 4. Okay? That's the only equation that I'm impacting. I'm going to leave the top one alone. So I'm just going to stack that over here as 3x, a positive 5y, and 180. Okay? And now I'm going to do the math over there. Does that make sense? So I transform that bottom equation. That bottom equation does the exact same thing that 4x plus y equals 104 did. Okay? I just made every single part 5 times bigger. Does that make sense? Yeah. Okay. So we're going to add straight down, and what's that give me? Negative 17x. This is what we wanted. We wanted those two things, and we added straight down to go to 0y, right? And now I'm going to add straight down those two things. So what's 180 minus 520? 360? 460? Careful. Is it 460? Negative 340? Okay. So 340 plus 180 plus 40 is 120. Carry that in. So now that's a one-step equation, right? Should be a pretty simple one-step equation. Divide both sides by 17, negative 17. Or divide 34 by 17, it's 2, right? So 34 divided by 17, so this should be 20 as an answer for x. Hello? Yep. 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 Bye. All right, so get x to be 20. Now, where we find y, it's totally up to you. And you might find y different than the person, the neighbor sitting next to you. You might have found x different than the person sitting next to you. Okay? But if this x is 20, that means in all of these equations, that x there, that x there, that x there, can all be replaced with 20. Okay? Because those equations all came from the same picture, right? The x is referring to the same amount in all those equations. So I'm going to substitute that in. I try to think about which one's going to be a little bit easier to deal with. This doesn't look too bad. I probably won't put that one. Just looks uglier than these two, I think. So I'm just going to plug into the first one. It ultimately doesn't matter. If I plug that 20 in, the 3 times 20 plus 5y equals 180. We get 60 plus 5y equals 180. So 5y then is equal to 120. And y then should be, okay. You've got your x's and y's now. You should be able to go back up to your picture. Okay, we said x was what, 20? X is 20, y is 24. I should be able to plug things in and make sure that with the specific values of 20 and 24 and what they yield for those angles, do my relationships of equality and supplementary still exist. So when I go 5 times y, so 5 times 24 gives me 120 there. Okay. 3 times 20 gives me 60 there. And then x plus y, that gives me 44, right? Well, 44 plus 76, 120. Do you still have the relationships of supplementary there? You have the relationships of supplementary there. And you have congruency in those two. And that's kind of a built-in check when you find your x's and y's. To go back and do that. If I were to find x to be any other number than 20, we're not going to see those congruencies and supplementary ideas show up. Okay? Same thing if any other y value would have been developed. Okay? At any point, if you guys are struggling with systems equations, or really any time that you, my website is your #1 resource, your #1 tool. If you go to the bottom of the website, this is all your algebra review. This is all the important stuff that you need for this course in regards to last year's information. Click System of Equations, and you can go through. There's hundreds of video or hundreds of examples throughout there that you can watch. They explain it as if you're in an Algebra 1 class and it's being explained for you the first time ever. But you have to take that initiative on your own if you want to be good at this stuff to go watch those. Does that make sense? Okay. We're going to use system equations throughout the rest of the year. They don't go away. They become very useful in other math courses. When you get to like advanced math, you get to calculus. In one section, they might kind of ping pong back and forth between, question 1 might deal with systems of equations. Question 2 might have a rational equation. Question 3 might have a logarithmic equation. Question 4 might ask you a factor. Okay? And you're doing all this algebra back and forth. That was the prerequisite information. Okay? So that's the hope, is that we start to refine those skills. We will, the first time, I know we had to jog your memory of what systems of equations were and how to deal with them. But I can't spend 3, 4, 5 weeks on it like you did last year to learn this stuff again. Does that make sense? Because I still have to teach you the geometry. But when we first introduce a problem and you see a new process for the year, we'll talk about it. Okay? So eventually we'll see factoring. Guys, you remember factoring? We'll spend some time talking about factoring. But I can't get into it as deep as Mrs. Coles or Mr. Herr did last year. So that you're going to have to go to the website and you're going to have to find videos and brush up on that stuff. Okay? Please understand that's, I know you probably haven't seen it before in other courses and had to do this in other courses, but beyond this, in high school, in college, you sign up for college and it has a prerequisite for it. Okay? They understand, or they make the assumption, even though you might have gotten a B or C in that prerequisite, you know everything that was in that prerequisite. They're not going to teach that stuff again. Makes sense? Some of you are in chemistry or biology or whatever, right? And you think, well, he didn't teach this stuff. He didn't teach me how to do unit conversions and stuff like that. That's because it's a 7th grade, 6th grade standard. Those are prerequisites, okay? How to change feet and inches and stuff like that. So they're teaching based off of those ideas. I don't do that because I know we missed some stuff at prior years. I want you guys to understand, so it's not an eye-opener when you get to college. A prerequisite is a prerequisite. It means you know that information. And if you don't know it yet, you have the tools to find it and learn that information. The video, so if you're still starting on that homework, or you're preparing for tomorrow's test, that video that we just did will be posted. Video from period 4 is going to be up there as well, period 5. 6 and 7 will also be up, so you have more examples to look at than just what we went over in class.